Alright, this is the video for 5.3 and 5.4. This just says 5.3 on this page. We'll kick over to the next page when we start 5.4. Alright, this is really about, the heading of this section is finding values. Finding values. This is the reverse or inverse of what we were doing in 5.1 and 5.2. In the earlier sections, we were given data values and asked for a probability. In this section, we are given a probability and asked for a data value. Alright? There is a built-in function for this on our calculator. It'll be second, distr, and then option 3 is INV norm. The inputs you give it are the probability, the mean, and the standard deviation. And then just like with the normal CDF, if you select INV norm and leave off the mean and the standard deviation, the calculator will assume that the mean equals 0 and the standard deviation equals 1. Alright? In other words, if what you want is a data value in a standard normal distribution that matches a given probability, all you got to do is select INV norm and put the probability in. Alright. This function returns the data value with the probability that matches the probability you entered. What that means is if you entered, for example, 0.05 for the probability, you will get the value that is bigger than 5% of the values in the distribution. This is also called the fifth percentile. So I'm going to draw a little picture to illustrate this. So here's a graph of a normal distribution. Alright. Here's the mean, whatever it is. And let's say right here is where this area right here, right there, that area is 0.05, alright? What the INV norm will give you, if you put in 0.05, it will give you this value, this number right here, whatever that is. Okay? And if it's standard normal, it would be one thing. If it's a different normal with a different mean and standard deviation, it would be a different number. Whatever number it is that has 0.05 on this side, that's what it will give you. Alright, so let's do a few of these. So this one says find the z-score, right? Z-score, so that means standard normal, that has 0.785 of the distribution's area to its left. Okay? Alright, well this is the easiest one. This is the one that the function is designed to do. INV norm 0.785, close parenthesis. That's all you got to put in your calculator. Since it's standard normal, if the calculator will assume that if you don't tell it any different. So I picked second distr, INV norm 0.785, close parenthesis, enter. We get 0.789 or 0.79. Typically most of these where they ask you for the value, they usually do 2 decimal places or sometimes 1 depending on the situation. Alright, next question. Find the z-score. So again, we're standard normal, right? Mean equals 0, standard deviation equals 1. That has 0.785 to its right. Okay? Now, remember the function gives you the function on the calculator will give you the number that has 0.785 to the left if we put 0.785 in, right? So if we want 0.785 to be to the right of it, right, so that would be something like, I don't know, maybe here, so that this area over here would be 0.785, right? Then if this is 0.785, what is this? Well, 1 minus 0.785 equals 0.115, right? So this is 0.115, and that means that what we're going to do then is INV norm 0.115. Alright, second distr, INV norm 0.115, close parenthesis, enter, minus 1.2. Or whatever, if it asks for 2 decimal places, then you'd give it minus 1.20. Alright. Find the z-score for which 80% of the distribution area lies between minus z and z. Now this is the one that I get the most questions on. So let's look at this. So here's a normal distribution. Okay. Here's the mean. This is a z actually, so it's going to be 0, and the mean is going to be 0. Now, 80% lies between. Now, minus z and z, that means that's symmetric, right? So something like this, if minus z is here, then z would be like the mirror image over there. And what they're saying is we want to pick our z so that minus z and z has 0.80 of the probability in the middle there, right? 80% lies between. Well, the way to do this is you just have to think about it a minute. So if 80% lies in here, how much lies outside, right? So 1 minus 0.80, so that means 0.20 of the probability lies outside, right? Below and above. Well, how much is below then? Well, this is split evenly, right? It's symmetric, minus z and z. So 0.20 divided by 2, 0.10. So that means this area right here is 0.10. All right? So I and V norm, 0.1, or if you want to do 0.10, either way is fine. Let's see what we get. Second DISTR, I and V norm, 0.1, close parenthesis, enter, minus 1.28. All right. So that would be the minus z, right? So if minus z then would be 1.28, then z would be positive 1.28. And that would be the answer to that question. All right. Let's do some that are not standard normal. So let's look at this question. Sleeping times of medical residents. The average time spent sleeping in hours for a group of medical residents at a hospital can be approximated by a normal distribution as shown in the graph. A, what is the shortest time spent sleeping that would still place a resident in the top 5% of sleeping times? All right. So really what we need, this is just kind of a fun way to tell us what the mean and the standard deviation are. All right. So we want the top 5%. So that's something like here, where this area right here then would be 0.05. So if this is 0.05, what's this? Well, 1 minus 0.05, 0.95, right? So that probability or area, however you want to say that, is 0.95. So now we just need I and V norm, 0.95. And then since this one is not standard normal, we've got to put in the mean, 6.1, and the standard deviation, 1.0. And let's see what that gives us. So second DISTR, I and V norm, 0.95, comma, 6.1, comma, 1.0, close parenthesis, enter, and I get 7.74. So that it put me in the top 5% or the top 0.05 of sleeping times. I get 7.74 hours, I presume, per night. That guy's doing, that's pretty average. That's as much as I get. So that was A. Let's B. Actually, that's more than I get. Between what two values does the middle 50% of the sleep times lie? All right. So let's draw a little picture here. Middle 50%. All right. So here's our normal distribution. Our mean is 6.1. Well, the middle 50 again means it's symmetric, right? So you want something where you get like 0.25 here and 0.25 there, where these two are, this whole thing is symmetric. Okay? Well, this is 0.25 and this is 0.25. All right? What does that mean? Can you see that that means that this must be 0.25 here and this must be 0.25 there? Hopefully that. Okay. So let's call this one, just for something to call, let's call this one x1 and this one x2. All right? So x1 has probability or area, we're going to call that 0.25 of it to the left. So that one is going to be I and V norm, 0.25, and we're still in the same situation here where the mean is 6.1 and the standard deviation is 1. All right, so let's see what we get for that. second DISTR, INV norm, 0.25, comma, 6.1, comma 1, 5.43. And then for x2, INV norm. All right, well, what area is to the left of this one? Well, 0.25 plus 0.25 plus this third area is also 0.25, right? Is 0.75. All right, second DISTR, INV norm, 0.75, comma, 6.1, comma 1, 6.77. All right, so there's our two numbers. These are the two values that the middle 50% lies between. Now, notice, since these are both 0.25, these two are going to be, if you do a little subtraction from 6.1, you'll find that these two are both the same distance from 6.1. So you could have found them that way, found the second one that way. Once you found the first one, you could subtract it from 6.1 and then figure out the second one. All right. So that's the way these work. We will be doing this kind of thing frequently in Chapter 6 and 7, although in 6 and 7 it's generally going to be the standard normal. Okay? Well, it depends on how you do 6, but we will do the inverse norm function quite a bit in 6 and 7, so you definitely want to get this down. Okay, well, this video took, the 5.3 part took longer than expected, so I'm going to post this as its own video and then do a separate one for 5.4.